Glad you can make it back here again with me, Mr. Cox at Math Rocks with Mr. Cox. This video is going to be about multiplying polynomials. So for instance, right here we have what we call a binomial multiplied by another binomial. So you'll learn a technique for that. It's a technique that always works and not only gets you the answer, but make sure you don't miss anything along the way because it's easy to do that. And we'll also take a look at things like a monomial, which is one term, times a binomial. And finally, we're going to take a look at a binomial times a trinomial, which is three terms. So if this sounds like it's something interesting for you to learn about, stick around and find out more. Let's get it on! So as you learn about how to multiply polynomials, by the way, poly just means many, so it could be one term or two term or three terms or even more. But we're going to first take a look at this one over here, which is where we're going to multiply one binomial times another binomial. So this is essentially like a 2 by 2 sort of math problem here. And so the technique that I like to show people is something called generic rectangles. And it's generic because you're just going to make one big rectangle. And in this case, I'm going to make it into a 2 by 2. And that's because we have two terms times another two terms. And then what you want to do is simply this. Take the first term, and I'm going to write 2x right here, and I'm going to write plus 3 right here. And then I'm going to take my other set here, and my first term is the 3x, and my second term is a negative 4. So here I have my binomial times a binomial. And the reason why you do that is you have to take each term in the first one, which is 2x plus 3, and you have to multiply it by each term in the second parentheses. So let's go ahead and do that right now. So 2x times 3x would be 6x squared. 3x times 3 is 9x. I got 2x times a negative 4. Well, that will be negative 8x. And then finally, 3 times negative 4 is negative 12. And typically what's going to happen is as you do this, we usually, not always, but at least one term and another will combine together. So in this case here, when we add all these in red together, we're going to have a 6x squared. So this is going to be part of our answer. And then secondly, we're going to add 9x minus 8x together, and that's just 1x, or I'm just going to write x, and then we have a negative 12. So look for some terms inside the boxes to actually combine together. And then, like I said, I love this method because it just ensures that I don't miss anything when I'm multiplying two terms by the other two terms. All right, so how does that look when we have something a little bit different? So this is the infamous monomial times a binomial, and I already have it set up over here. So I made a generic rectangle, and because this is a 1 by 2 situation here, I'm going to go ahead and make it so I have 1 by 2. I have 4x on the side and 2x minus 7. And this one is probably the easiest of them all. It'll just be 8x squared minus 28x when you multiply negative 7 times 4x. And therefore, what is your answer? It is 8x squared minus 28x. So always make sure you look in the boxes here and see if you can combine like terms together. In this case, you can't, but usually you can. So now let's go ahead and take a look at this one over here where we have a binomial times a trinomial. So you see my generic rectangle has been made into a 2 by 3 grid. So I have two terms along the left side here and all three terms along the bottom. So let's go ahead now and multiply together. So 2x times x squared would give me 2x to the third. Then I take my x squared times my 1. That would be x squared. 1 times negative 5x would give me this over here, negative 5x. 2x times negative 5x would give me negative 10x squared. 2x times 3 would give me 6x. And finally, 1 times 3 is 3. And like I was saying earlier, look for things to combine together. So for instance, I have two different terms involving x squared, so I'll be combining those together. And then these two terms here, I'm going to combine together as well. So let's go ahead and do that right now. So I have a 2x to the third. That's the only x to the third in any of the 6 boxes. I have x squared. So that's a 1x squared minus 10. So 1 minus 10 is negative 9. So I have a negative 9x squared. And then I have 6x minus 5x. That's a plus 1x. And then I have a plus 3. So that's my answer altogether. 2x to the third minus 9x squared plus x plus 3. And certainly, as you can see here, it does get a little more complicated as you add more terms to the mix. and that's why I love the technique of generic rectangles. If you like what you've seen and heard so far, please like, comment, or subscribe. Thank you, and back to the show. So now it's time for you to see your skills that you've hopefully acquired through the video so far. So I made up a couple of problems. One is a binomial times another binomial, and then we have a binomial times a trinomial. So what I'd like you to do right now is, as it says on the screen, pause the video and then try these two problems on your own. And in a few seconds, I will show you my solution so you can see how you did. All right, so here are my solutions. So I made a 2x2 grid over here, or generic rectangle, and you'll see that when you multiply 3x times 4x, you get 12x squared. 4x times negative 2 is negative 8x. 8 times 3x is 24x, and negative 2 times 8 is negative 16. I'm going to combine these two together because they both involve x, and my final answer is 12x squared. These combine to be 16x and a minus 16. Likewise over here, I'm going to make my generic rectangle and make it into a 2x3 grid. And when I multiply together, I get all these different answers here in the boxes. And when I combine like terms, you can see with the red arrows here which ones go together. I get 3x to the third. These two combine to be negative 13x squared. These two x's combine to be negative 34x. And then we have a 24 sitting over here. So I hope you got a lot out of this video and you now understand how to use generic rectangles to multiply polynomials. Thanks for watching.